Hello and welcome to another video about the new Solana Web3.js. It feels like it hasn't been long since I made the last video on that topic, but they have a release candidate, an actual release candidate, not just a technical preview. So that is gonna be the thing that they are gonna want to release. Hence, release candidate. And I want to have a look at it, because now is probably the last time to have a say in how that stuff should look like before it's actually released. And I'm not gonna hold that whole conversation why it's good to give feedback right now. I've done that in all of my previous videos about the Solana Web3.js. TP2, TP3, TP4. So today, I just want to have a look at if there's anything else that changed since the TP4, the last technical preview, potentially play around with that, and just have a look at the structure of the new Web3.js, because it is much more modular than the old Web3.js where there was just everything in one. Now we have those different things that we already had a look at last time, but I want to give a better overview on what packages there are and what is in each package. That's my plan for today. I haven't looked at this release candidate. Maybe I'll find other things that I want to have a look at, but let's have a look at it. Solana Web3.js. Look at this. The new Web3.js release candidate RC1. Bit more than a week ago. Version 2, release candidate 1. Soon TM, we're gonna go to version 2 of the Web3.js. Wait, there was a first release candidate already? Oh, yes. There was this is already the .1 is already the second release candidate. There has been a release candidate. RC0. Oh yeah, we're computer scientists. We start at 0. Interesting. So that was 2 weeks ago. And last week, so 1 week ago, this was published. Oh, that's nice. So great. People are giving feedback for the release candidates. Great job. Keep doing that. Maybe we get ourselves an RC2. This is still the best time to get in your feedback. So, but let's start from here. This is an open invitation to test out what we intend to release as version 2. Your feedback in this final moments before release will help us catch any bugs and rough edges that we missed during development. So let's get the release candidate. Wait, hold on. First, I make myself the node modules folder in here, and then I install into that folder. Again, we don't want to mess with other installations of the Web3.js that I might need somewhere else. So, got the release candidate. Try the runnable examples in examples. Use the example dep. It's also available here. Install type. So, really, I hope that in this video we're gonna learn as well how to properly use the Web3.js by actually looking at the examples. Last times I was always just, trying to figure it out by myself, but there are examples now. So that's how the devs of the new Web3.js intended to be used. Maybe we should have a look at that. Install TypeScript clients, on-chain programs like system token. Aha, so that's where we find them. Solana program/system. They are now all separate packages from Solana program. So Solana program is its own GitHub account, has the memo, stake, token 22, compute budget, address lookup table, system program stuff. Then the client stuff, which has been generated. Interesting. Oh, we have a release date as well, shortly before breakpoint. Okay, so good time to give feedback. Changelog since the TP4. Let's go through this real quick. Dev mode will now be the default so that fewer people accidentally find themselves in production mode. Okay, that makes sense. Cool. We don't need to look into that. Fix the type of config on get compute estimate for transaction message. It's now optional and does not include transaction message. Ha! Is that something that I complained about in the last video? I think so. Is that how I need to put it? Yeah, that was me. Why? Fixed it. Well done. I don't know if they saw my video, but at least they fixed it. Then, Titan return type of is program error. Whatever that means. Added a use sign in hook. Returns a function that you can call to trigger a wallet's sign in with Solana feature. Ah, cool. So now we have the sign in with Solana feature. It's nice. Fix the bug. That's always nice. Add a function to replace accounts in a transaction message using lookup tables. Also sounds helpful. Then fix the type of config. Is that the same thing? Okay, so that's just duplicated code. But they fixed it twice. No, it's the exact same. Okay, sweet. We're 195, or we're getting close to 2. I wonder what happens to the old one, how long that's still supported then. But let's not worry about that. Let's just say, hey, you should be using the new one then anyway. Okay, so no like major changes that I see here. So there's nothing that I really need to have a look at. Oh, we should check that out. No, it's just like, yeah, it's good. But maybe there are changes with the RC1 because people found bugs and they were fixed. Special thanks to Wilfred. Also, new in this release are handy tools that help you load keypairs. Yes! Finally! Tools to load keypairs. That's what I want to have a look at because that's something I always do. And if there's a nicer solution for it, that's just super helpful. And to derive public crypto key instances from private crypto key instances. Let's also check the changelog for this one. So they added a create key pair from private key bytes. Oh, that gives you private key and public key. You just put in the uint8 array. I don't know how I've been doing it, but that seems more convenient. Although I'm not sure what the types of those are. But that's certainly one thing that I want to have a look at. Solana keys. Again, it shows it's all modular. You don't need to import that stuff if you don't need it. But if you need it, you can just import it. Then add a get public key from private key. Given a private key, gets the corresponding public key. Extractable public key. What's the difference here? Another thing I want to have a look at. Then add a create key pair signer from private key bytes. Compose create key pair from private key and create signer from private key. Yeah, that was also always like an annoying thing. First you gotta get that and then you can get the signer from it and then you have those two things. But probably for most things we are happy just with the signer. So having one function that gives me the signer directly, also helpful. Ooh, a helper where you can raise 2 or more promises without having to worry about them leaking memory. Again, something I want to have a look at. Also, there are a lot of things that I do want to have a look at. Ah, okay, so it settles when the first one settles. Solana promises. Interesting. Then, Stephen Lucia, create a package for dealing with JavaScript promises. So, again, Solana promises to deal with promises. Fix a memory leak with transaction confirmation and subscriptions. Yeah, memory leak fixing, always good. Cool. So should we first have a look at those and then look at the examples? I think that's the way to go. I would like to have a list of all of those packages. Where did I see that? They had it in a changelog. Oh, there. Solana Lab, Solana Web 3. In the README maybe? Ah, what's new in version 2? Yeah. Tree shakeability. Object-oriented design prevents optimizing compilers being able to tree shake unused code. You have until now been forced to package it all. Version 2 is fully tree shakeable. So that means you can, shake off branches that you don't need. Shake the tree and just keep the branches that you need. And everything you don't need just falls off. Optimizing compilers can now eliminate those parts of the library that your application does not use. The new library itself comprised of several smaller modular packages under the Solana organization, including, that's where I wanted to go. So here we have all of those packages. This is a non-exhaustive list. There is more. Some of the packages themselves are composed of smaller packages. And so that makes it really tree shakeable. Developers can use default configuration with the main library or import any of its subpackages where customization through composition is desired. So that's the one thing, the tree shakeability. Then we have composable internals as another advantage of the new Web3.js. You may wish to configure your application to make different sets of trade-offs than another developer. The old one imposed a rigid set of common case defaults on all developers. Mango team wanted to customize the transaction confirmation strategy. Set a backup URL in case of the primary one failing. Time window batching. Custom retry logic. Oh yeah, that was a thing that people wanted. That was really difficult with the old Web3.js. You basically had to build it yourself anyway. So version 2 exposes far more of its internals, particularly the RPC communication. which allows developers the ability to compose new implementations from the default ones that manifest a nearly limitless array of customizations. Wonderful. We love our customizations if we want to do something custom. Yeah, we also saw there's a lot of super types, for instance, with the key pair or even the connection. There's the general connection, then there's the Solana connection. Just in case you want something, you know, specific, and then you can, you know, plug in your own thing. It encourages you to create higher level opinionated abstractions of your own. In fact, they expect you to do so and then open source them for others. Cool. Another advantage, modern JavaScript, zero dependency. With modern JavaScript, we have the ability to use the ED25519 curve keys to express large values as native big int. I guess that makes it more efficient. Web crypto API is already in most modern JavaScript runtimes. Engine support for big int. So apparently in JavaScript the number only has 53 bytes as compared to 64 of a U64 that we use a lot in Rust. So, you know, big ints you can't represent with a number. That's why this big int support is so important. Another advantage, the functional architecture. Oh yeah, if you like functional programming, the Web3.js is pretty cool for you. I mean, in school we always learn object-oriented and how that's so great, but in certain cases, like here, functional definitely is better. If you don't know what I'm talking about, that's fine. It's a different way of, you know, thinking about development. You don't have your object, so this is the thing, this is the thing, this is the thing, but you have functions that go in each other and then the result comes out. And you know, in version 2 we have no classes except for Solana Era. It implements the thinnest possible interface at function boundaries. Cool. So that's all just motivation why the new Web3.js makes sense or what's better. Here's some statistics on what's better. The library is smaller, different metrics for how it's smaller. Performance of key generation, it's a 10x. Nice. The Explorer also loads faster. And here we could go on a tour of the new Web3.js. And maybe that whole thing could be a topic for yet another video on that thing. Because goddamn, that Web3.js has a lot of features, I tell you. Can't talk about everything today. Oh yeah, type safety is also a big topic. All super typed. Okay, thank you. Coming back to here, we wanted to look at those things. So let's do it. I think I'm still missing a load from file. Maybe there is something like that, but let's have a look. So Solana keys takes the bytes. I don't know what extractable is, and I don't have the docs from that. Can I like download that with documentation somehow? What did I do so far? In the TP4, I got myself the bytes. I read that from a key pair that I have stored locally. So that is still a bit annoying. And then I use create key pair from bytes. And now I can create key pair from private key bytes. Gives me a crypto key pair. And this thing also gives me a crypto key pair. I guess it's the same thing if I import it from Web3 or keys. Keys is probably just within the Web3. So I can import it from Web3 directly. But that doesn't explain what the difference to create key pair bytes is. Wow, okay, that again, those things just confuse me. So apparently it's different bytes. One is just private key bytes and the other one is bytes. What's stored if I have this JSON file? I always thought that's just a private key. Anyway, let's just play with it. Let's get ourselves some bytes. Release candidate 1. No case. There we go. Helped. So that's the bytes, you know, just a random private key. Is that just a private key, or is that also, you shouldn't usually show that unless you don't intend to ever use that key for anything. But is that now the private key, or is that the key? Like which of those do I now need? Let's try both, because I don't know what bytes those are. Here I get a crypto key pair. Here I also get a crypto key pair. Explain me the difference, please. Gonna wait both of them, print both of them. Let's see what that does. Solana Era. Solana Era keys invalid private key byte length. Aha, so looks like the private key, this is not a private key. Let's see if the other thing works. Yeah, this works. There I actually get a private key and the public key. Cool, we'll learn something about Solana keys now. I always thought this entire thing is the private key, but hey, maybe it's just the first, I don't know how many bytes, and then comes the public key, who knows? Because that would, if that was the case, I really want to know. Let's do the private key thing. And then it complains that the length doesn't match. How long is a private key of this curve? Invalid private key byte length. Okay, so it expects the private key to be only 32 bytes. I thought the entire private key is 64. Wow, okay. Why did I think that? Are Solana private keys really just 32 bytes? I mean, 32 bytes are still a lot. I mean, 2 to the power of 32 times 8 is still a lot, but yeah, Bitcoin also has 32 byte private keys. I thought Solana had more. Ethereum as well. Okay, learned something. How do we have more addresses then? So just the address space is bigger, but not the private key size? Apparently. Well, the things you learn while you have a look at the new Web3.js. Completely unrelated. Well, related, since the Web3.js has... Anyway. So, then it's just 32 bytes. So, would I use the first 32 bytes here then? You think that would give me the same? At least it's not failing anymore. Can I now get the keys for that? Public key. How do I get the... And then from the signer we have the address. Import that from here. But also, I think both of them, all of those things are actually in here as well. Nope, not the signer. Okay, give me the addresses. Interesting. Turns out, indeed, only the first 32 bytes of this is the private key, and the second 32 bytes of this is not important anymore. It's just the public key, which we can derive, I guess. So it's literally a key pair that is stored. So I got that wrong in some of my previous tutorials. I'm sorry. Turns out I'm not perfect. Haha. And I don't know everything. And this is actually a literal key pair, not just a private key. Good to know. We learned something really important here right now. Because that means even if I share the first 32 bytes of this, they have full access to my wallet. Even if I cripple this private key and, you know, steal a few bytes here, that will still work, except it won't. The second one will die. So from bytes, this one won't work anymore. But we still get the correct public key. Freaking interesting. So give the bytes back. Is there a create public key? What's the difference between a private and a secret key? Oh, there's so many things that I still need to learn about all of this stuff. I mean, that's a nice interface, but where's the actual bytes of this thing stored? And the address is also just a string, right? So I'm still not sure about types here. I wanted to get the public key just from those bytes, or the bytes from the public key somehow to just compare. I don't seem to manage. It was easier with the old Web3.js. But okay, let's just quickly do it manually. If I have this pub key, hold on, I can just base 58 decode that. Default export and decode, fine. And then we get an array, that's what I want. And there is a way, probably, how to get from this public key thing that I have here in my signer. This has a key pair public key. Somehow I can get to those bytes directly, but don't ask me how, so I just decode the address. Lol. Not how you should do it, but just for myself for checking. Oops. I'm interested in the actual bytes. So is that what I also have in my key pair file? Yeah. 8615. So apparently it's literally a key pair with private key, public key. Wow. How long have I been working with Solana Keypairs? 2 years? It took me 2 years to figure that out? Wow. Sorry about all the misinformation that I provided. Especially sorry because it's like a security topic. Damn. Alright, good. The new Web3.js made us learn stuff. Wonderful. Moving on now. Let's not do that weird stuff. So we learned we can read the entire key pair with private key, public key, or just the private key. So that's just the 32 bytes. And then they also have this new create key pair signer from private key bytes, which is in Solana Web3.js as well. Maybe even in here. Nope, it's in the Web3.js. And that thing basically does those two things together. So signer 3 is again the same thing. If I await this thing and I can provide it the same things, the bytes, and if it's extractable. Still don't know what extractable means, damn it. Maybe that I can get the private key out of the signer thing here? Not sure. I will also just need the private key here. Boom. And that should then again be the same thing, because that basically does this plus this. That's the same. Yeah. And it gives me the same public key. Address is what they call it here. Cool. That's the whole thing with the keys. Given an extractable crypto key private key gets the corresponding public key. So the one thing is a public key and the other thing is an extractable public key. What's the difference? Okay, let's say I have a private key. Get public key from private key. Did I import something else? Maybe I have the wrong version of the Web3.js because it's certainly not in here. Is it in here? Solana Web3.js has no such member. Solana keys, but it should be in keys. Hold on. Keys also has no such member, which means I might have the wrong version because that is new in the RC1. I mean, both of them say I should get it with RC, but maybe I need a different tag. How would I find that out? At RC1. Nope. RC.1. Nope. At RC, I already have that. Compatibility. There's a compatibility thing. That's also fun. Let's look at that. Because I said, oh, it was all better in the old Web3.js. Let's install the compatibility version that doesn't exist. There, at release candidate, it works. Okay, perfect. We added one package. And what's in here? So it's just from legacy key pair and from legacy transaction. That's all that's in there. But the actual type of the legacy, so I would also need to have the legacy pub key, which is difficult to get if I have node modules here. Okay, never mind. And also this is just not here yet. Maybe this is just not updated. Maybe this hasn't been pushed. I mean, again, this has been released less than a week ago. Maybe it just didn't make its way yet. But the create keeper signer from private key helper, that made its way. This one, I don't find it. It will come. That will somehow find its way there. And I also still don't know what this extractable thing means. In the context of Solana keys library, the code we provide, the extractable flag is used to specify whether the generated key can be extracted or exported from the Web Crypto API, allowing it to be converted into different format or reused. Okay, so my assumption was correct if ChatGPT is correct, which we don't know. But since it's super difficult to find any docs on that stuff, I will for now trust ChatGPT unless I'm proven wrong. It indicates whether the derived pub key can be exported or not. If true, you can later extract the public key using functions like crypto export key. So really, we're using the Web Crypto API. That's what's behind all of that. So that's not really Solana Web3 specific, but that's the Web Crypto API. And that's also why ChatGPT knows about it so much. If false, the key remains non-extractable, making it more secure against unintended distribution, but less flexible. That makes sense. So somehow the library itself protects against getting the keys out. Okay, so let's try that here. Because we have the extractable, even if we don't have that specific function, but we have the create signer and here the from private key. Maybe let's do one like this and one extractable, where I set extractable to true. And here we set it explicitly to false. Let's see what the difference is. Let's just print the whole thing. So here we have extractable false, public key is extractable. And here we have extractable true and public key is also extractable. So from this one, I should not get the private key. And from this one, I should get the private key. But how? Format raw, and then the crypto key. Comment of type raw is not assignable to, you need a private key. Okay, cool. So that's the raw thing. I have no idea what I'm doing. Exported raw key. Oh, that's just, perfect. That's a buffer. That's exactly how I like it. Key is not extractable. Nice. Invalid access exception. True, because I tried to do this on the non-extractable one. And if I have the extractable one, then unable to export a raw ed2 private key. Fine. Okay, so there we have another issue with the, okay, how can I then export it? Like this. Then you are a JSON web key. Sure. So as a JSON web key, I could export it, but I don't think that that's any useful. Maybe from that I could get to the actual private key again. What other formats are there? Oh, that's a buffer again. 48 bytes. I don't know what all of those things mean. I'm not that deep into. Yeah, anyway, but we see that we can somehow extract the keys. Let's try the public key, because that should also be extractable. Yes, so the public key I can export as raw. Wonderful. And there it gives me the bytes. Ha ha ha. And that's the thing that I also tried earlier with the base 56 decoding. Probably we get the same thing. Yes, we do. I see the 56, which is actually an 86 in decimal. So a 5-6 hex. And here 5-6 hex. And the 0f is the 15. That's the 15. So that's the public key. That's how we got the public key. From the extractable. And we could have also gotten it from here, because that is also extractable. The public key of those is always extractable, unless we create the public key as not extractable like they do here. But I don't have the get public key from private key method. For some reason, I don't find it in my... And good enough. I spent enough time on this, playing around with crypto keys here. A whole episode just on crypto keys with the new Web3.js. But hey, we learned important things about Solana Keypairs. Good. I think I'll leave that topic. Should we still look at examples? Yeah, we said we look at examples. Let's look at examples. Web3 examples. Maybe we find something interesting in here. I just cloned the entire thing in here. What could possibly go wrong? And then we should have the examples. Let's check out the transfer lamperts. So what's happening here? We don't have that. Okay, that's fine. Creates key pair signer from bytes, and those are the bytes. So it literally just hard codes the bytes of this address. That's the private key. So that's 32 bytes. Yes, 32. Okay, no, it's the entire 64. Create key pair from signer. Creates a signer capable of signing using the 64 bytes key pair. Okay. Wait, didn't I just do it with the... create key pair signer from private key. Okay, so the new thing is just the from private key. There was also a create from bytes, which I can also import from Web3.js. Okay, so the new thing was just to get it from the private key bytes. That's what they added in the RC1. I see. For people who just want to work with those. Edge use case, admittedly, but yeah. Saves you knowing your own pub key. And saves me from continuing to think that Solana has 64 byte private keys. So wrong. So wrong I was. So wrong. Anyway, what else is in this example? That's how you create an address. We also know that. It's just with that address thing, because that will also check if it's a valid address. And then we create a Solana RPC on localhost. Okay. And also a WebSocket connection to localhost. With that factory, we create the send and confirm transaction. Then we get a latest block hash. And then we do the pipe. Inside the pipe, we do some logging. So there you go. That's if you want to know how to do logging inside that pipe. First, we create a transaction message. And then you always pass through that transaction. Then we set transaction message fee pair. Then we set transaction message lifetime using block hash. And then we append transaction message instruction, a get transfer sol instruction. So that's from the system program, I guess. Yep, Solana program system. Amount lamperts, destination address, source address. And then we need to sign the transaction. So we sign transaction message with signers. And the signers are already in here because we put them in here. Wait. Here we put in the entire source account signer in this instruction. And that's, I guess, how he then has the source account signer to actually sign, I guess. Because at the fee payer, we just set the address. This is still a bit confusing to me, admittedly, but I guess that's how it works. And here, this example is just highly documented and not so super easy to read. But it's the same thing as we did last time, so I don't want to go over it in detail again. So if you're ever lost, look at one of those examples. There you will find the correct method, the correct functions to do the stuff you want to do. And then we send and confirm with a get signature from transaction. Wait, here we just print the signature and then we actually send it here, okay? The signed transaction with a confirmed commitment. And when that comes back, because we awaited, then it's successful and it gives you a press any key to quit. And otherwise, we can see if it's a Solana error, this E here. Oh, that's also cool. That I haven't done yet to decode such an error. You know, anything can come back here from the send and confirm. And we check if it's a Solana error. Oh, and it checks if it's a specific Solana error, this one. The Solana error, JSON RPC server error, send transaction pre-flight failure. And if it is that, then we know it has a context and a message, and so we can just get that. If it's a system error, get system error message. Otherwise, get the entire message. Okay. And otherwise, if it's not that error, we throw that error ourselves. Cool. Yeah, the whole error handling, we do it there. I'm sure more errors like this. Yes, bunch of errors. A bunch of errors. All of the Solana errors. Yeah, and that's an example. Again, I don't want to, you know, go through this in detail. We did that in previous episodes. Let's see another example. Never commit your key pairs. Hey, signatures add transaction message fee payer. Oh, that's how you can access the first signature. Because that's a signature map. I mean, that makes sense. The signature of the fee payer is always the signature that represents the transaction. Partially signed transaction message with signers. So we never need to provide the signers here because they are already in that transaction when we build it. Keypair signer from file. That's what I always do. How is it done properly? You get the path to your JSON file. Yeah, and then you also just JSON parse and the read file, this key file, and then you get a uint8. I guess you need to do it that complicatedly. But then those bytes you can put in there and get your signer. So this step with the create key pair from bytes, this you can skip by just using the create key pair signer from bytes, because you only ever really need the signer, is what I learned so far. Yeah, because the signer has the address and it's good enough. It's a transaction signer. Key pair signer from seed. Wait, what was the option 1? Option 1, generate a key pair sign. Just generate a new signer. Option 2 was from file. Option 3 was from a seed. Well, same thing, but the seed you just have here, the 32 bytes. We did have a look at that, just that I also got the 32 bytes from my file, but it doesn't matter. Then we have a create key pair signer from private key. It's all in the examples. It's all in the examples. Option 4, a no-op signer that pretends to sign messages without actually doing so. We can use this if a function requires a signer, but we don't actually want to sign. So create no-op signer and we just give it the address, or we pretend that we can then create signatures for that, but we don't actually ever sign with it. So we just put it in without signatures. Cool. That's also good to know if we ever need that. Cool. That's the signers example. Do we want to look at a custom RPC? Do we want to look at the React app? Deserialize and inspect the transaction. So here we build the transaction message. It's a transfer and then I add memo. Fetch JSON parsed account. Lookup table data. So that's how you work with lookup tables. Transaction message with lookup tables. Compress transaction message using address lookup tables. So we have the regular transaction message. That's how far we got last times as well. And then lookup table, address lookup table, data account. That's weird. What does this take? Oh, this is so difficult to read always. The transaction message and then the address by lookup table address, which is address by lookup table address. What is that? That's what we put here. Okay. We partially sign. Get base64 encoded wire transaction. That's how we then encode that transaction. Those things we haven't tried yet. And that's interesting to know how that works. Again, if you're lost, look at the examples. They usually have what you need. And then when we have that, so that's what we would send to the RPC, then we do the decoding. So that was just a setup for this decoding. Decoding step 1. We first encode the base64 encoded transaction to a byte array and then decode to a transaction. So we create ourselves a get base64 encoder Then we encode this base64 encoded wire transaction to transaction bytes. And then we get a transaction decoder, and then we transaction decoder decode. Interesting. And that we have the decoder transaction. Cool. And that thing has the signature map and the transaction message bytes. Then we can verify the signatures again with this crypto subtle. So here we get the public key. Haha. Okay, so that's the address, the literal address, s-base 58, and the get address encoder, encode by address. It's weird that the encoding encodes it from string to bytes, which in my head, this should be called decoding, but you know, whatever. Because for me, that is the encoding, a base 58 encoding. The bytes are decoded, but you know, whatever. So then the bytes we import as a public key, and then we verify signature, that this signature is actually the signature of this key for that message. Nice, okay. And that, where does it come from again? Yeah, okay, it is actually in the Web3.js. Okay. Then step 2, decode the compiled transaction message. So here we just got the transaction message. Well, the decoded transaction has the signatures and the transaction message bytes. And if we also want to decode the transaction message, we get a compiled transaction message decoder. Great. And then with that decoder, we can again decode the message bytes. And then we get a transaction message, which is a compiled transaction message. Great. And this thing we already had a look at, where I was a bit confused that it's so like low level, has the compiled stuff. This is literally just the bytes, but you know, in this object or in this type where you can access it. You know, here I can now be like compiled transaction message. Here I can get the header, the instructions, the static accounts, the transaction version, but the accounts and everything, that's just a list of accounts, and the instructions and everything, I can just get the instructions, and here I have the data, the program address index, and the account indices. So that's all very low level transaction, like, because it's a compiled transaction. It's already as small as possible as it goes on the wire then, right? With the account indexes and the program address as the index. That gives me the index to the static accounts. So if I access the static accounts at index, program address index, then I know which program is being called here. That's the compiled transaction message. Yeah, it gives us a compiled transaction message. We can look at the version, look at the lifetime, the static accounts, lookup tables. And then we can also decompile that transaction message. What did we do so far? Decode the compiled transaction. So decompile, here we had a compiled transaction message to get a structure that is easier to inspect. This is actually a really good example. I highly recommend that you go through that in your own time, slowly, because that we will need a lot probably, or having an understanding of those steps, building that transaction. Usually we do it the other way around. We build the transaction, then we compile it, and then we encode it. Here we did the other way around. We decoded and we decompiled. So there's a decode transaction message. We give it the compiled transaction message, and it needs the RPC connection. We won't send the transaction. We will use the remote procedure call to fetch the block hash and fetch the address lookup table. Okay. Why would you fetch the block hash? That should already be, or maybe you want more information. Let's look. Then we have the decoded transaction message, compilable transaction message. Nice. And this one has more interesting stuff like the fee payer, transaction block hash. The last valid block height is not encoded. Just the block hash is encoded in the transaction. So we can't decode it back out. The decompiled transaction message will fetch the current last valid block height. Okay. You could parse it in like this if you know the block height that you want to use. But that's just for the decompiling. If you then compile it again, then that's what it's going to use. Actually, no, just the block hash is what it's going to use. This thing doesn't really matter. We can also look at the instructions like this. Now we have the actual instructions there. So that's what we get from the decoded transaction message, the fee payer, instructions, lifetime constraint, that versions, which here is way more easy to look at. Instruction 0, for instance, here we get the actual addresses. We don't need to look that up again. Here the program address, for instance, is the actual address. We don't need to look it up at the static accounts and stuff. And the actual accounts and data, that's what we would expect from an instruction, right? Okay, moving on. What else do we do then? Can then parse the instructions. You know, okay, this is, if it's this instruction, then parse transfer sol instruction. And then, you know, and then you can look at the individual things of the instruction data and the accounts and be like, okay, it was this is the data, so it means it's a transfer, and so on and so on. So that's then parsing the instruction. Again, we usually do it the other way around, where we say, oh, please transfer this amount, and then we create the instruction, and then we compile it, and then we encode it. Parse memo instruction. Cool. That's it then. This is a great example. I love this. Again, highly recommend that you check out that example by yourself, or even better, try and do that by yourself. Set yourself the goal. Given a base64 encoded transaction like this one, we have a wire transaction. Get me all the information. Decode all of that information. So first decode, decompile, and then parse. It's pretty cool. Because that's what's happening every time. That's what the validators then do. They get the encoded wire transaction and they need to deconstruct what's actually happening here. We usually, as devs, do the other thing where we say, oh, we want to build that transaction. And then the result is that wire transaction that we send to the RPC. And at that point, we're like, okay, RPC gonna take care of it. Validator gonna execute the stuff. Yeah, but that's really cool. I guess I will need that in the future because I will certainly want to encode and decode stuff. And I now know where I can find an example for that in the Web3 examples, the deserialized transaction example. Good to know. Overall, the new Web3.js is quite cool. It will take some time to get used to it because it is very different to the version 1, but it is worth changing to it, I guess. I mean, purely, even if you prefer the old version, purely from the perspective that this one is going to be supported for longer, and with version 0 point something, you'll run into deprecations and at some point stuff is going to stop working. So I highly recommend that from breakpoint on, when this is actually going to be released, you want to use the new Web3.js. Now, we didn't get to look at all of those things. It's just, as I said, too big of a topic for one video. That's why I already made 4 of them. And there will be more of them. But I will stop here for now. We did learn a bunch of stuff. And we did look at the release candidate. I don't even know what I should put as a conclusion. Use the new Web3.js. If you're confused, look at the examples. Go through them slowly. It is okay that you don't figure out everything on the first day. It will take some time to get used to it. But if you're writing Solana applications in TypeScript, you do want to use the new Web3.js. Now I'm at the point where I would recommend it. Like, the release candidate is already close enough to the actual released version that I don't think there are gonna be many breaking changes anymore. Probably just a few more bug fixes and potentially a few more features. But it is time, and breakpoint is in less than a month. So it is time to get started using it. And who knows, if you're quick enough and you still find some things that you don't like, report them, add the issues, file a GitHub issue, and let them know what you want changed. And with that, I shall say goodbye. Thank you for watching this update on the new Web3.js. And really was just a deep dive on crypto key pairs, because apparently I didn't know enough about them yet. But it's good. It's good that we keep learning. Good that we keep learning. So thank you for watching and learning with me. Here's some other videos you can watch, like and subscribe, and I'll see you when the new Web3.js is actually officially released. You can count on me making another video then. And I will definitely make more videos about that because so many things to explore, and that is really the main interface for devs. If you want to get started with Solana development, you're gonna come across the Solana Web3.js. So we will need a lot of dev resources, and I will be one of the ones creating them. See you there.